Here we are, not in West Virginia. Clearly we're not in West Virginia. Okay, so before we get started, we love our joke of the day. So let's get started with that joke of the day. Why did the rocket lose his job? Well, he was fired. You know, you fire a rocket into space because that's where we are, is in space. All right, well, let's move ourselves. Let's fire ourselves into scientific notation. Now, scientific notation is not just used by scientists. That's a misnomer. And all this galaxy and space stuff behind me, it makes you think, oh, I'm not going to be a scientist, so therefore I don't need to know scientific notation. It actually has a lot of uses because anybody who's going to deal with some very small numbers, like for instance, if you are a biologist, which yes, that is science, but anybody who's dealing with small numbers, like if you're working with cells and molecules and various small things like that, scientific notation will be very helpful to you. Or if you're someone who's working with some very large numbers, like for instance, what if you are a financial person and you're dealing with billions and trillions of dollars? These very large numbers will actually be easier to work with if you work with them in scientific notation. So let's take a look at what scientific notation is. It is a number that is expressed in this form. A times 10 to the n. That is the format for scientific notation. Now, you need to understand that this A right here is going to be a number, and notice what it says, that number is between 1 and 10. Now, there's a very specific format to what I've got written here. Notice that it says absolute value of the A. In other words, this number here could be negative. That's okay for it to be negative. But what I'm looking at is I'm ignoring the sign on it, whether it be positive or negative, and I'm simply looking at the digits that are in that number. And I'm saying that those digits are between 1 and 10, but notice there's no equal to part right here. So is it okay for this number to be a 10? Absolutely not. Now, is it okay for that number to be a 1? Yes. There's an equal to part here, so it's okay for it to be a 1. There is not an equal to part here, so therefore it's not okay for it to be a 10. Now what that tells me is this number here needs to make sure that it has one digit to the left of that decimal point. One digit to the left. Now once I've figured that part out, this n, this exponent on the 10, can be an integer. Now we've talked about integers before. Integers leaves out what types of numbers? Absolutely. There are no fractions, there are no decimals in integers. Integers can be negative, they can be positive, but we're not going to have fractions or decimals in these exponents that are right here. Only positive or negative whole numbers, in other words, integers. So now that we understand the format of our scientific notation, we can convert from scientific notation into decimal notation, or we can convert from decimal notation into scientific notation. I'm going to start with converting from scientific to decimal just because it's the easiest to do. Now what I always like to say is the power's in the power. In other words, the power is in this exponent right here. And this exponent will move that decimal point. Now I know a lot of people think mathematicians try to make things very difficult, but we actually don't. We try to make things very easy. So it's kind of common sense how this thing's going to work. In other words, the number that's in that exponent, ignoring the sign, the number is going to tell you how many times to move that decimal point. The sign will tell you what direction to move the decimal point. And here again, mathematicians really do try to make it easy. Let's picture our number line. On that number line, where are all the positive numbers? Absolutely, they are over here to the right. So in other words, if that exponent is positive, that means that you're going to move that decimal point that many times, but you're going to move it to the right because all the positive numbers are to the right on the number line. Now, where are all the negative numbers? Absolutely, they are over here on the left. So in other words, if this exponent is a negative, you're going to move this decimal point that many times, but you're going to move it in the left or to the left because that exponent is negative. So like I said, it's kind of common sense in a way. So if these two examples say I'm going to write each in decimal notation, notice it's already started in scientific notation. Here's that A times 10 to that particular power. And like I said, the power's in the power. So this exponent is going to move that decimal point. So this decimal point is going to move 8 times. I just need to figure out, is it going to move to the right or is it going to move to the left? Well, this is positive, and all the positives are to the right on that number line. So this decimal point is going to move to the right 1, 2, 3, 4, 5, 6, 7, 8. And all of these empty spots, what would you logically fill into all the empty spots? Exactly, they're empty. So we'll put zeros in every one of these empty spots. So what I end up with is a 495 with 2, 4, 6, 7 zeros behind it. 3, 4, 5, 6, 7. And I'll start from the back. I'll come up and put a comma right here. I'll put another comma right there, and I'll put another comma right there, giving me my answer of 4,950,000,000. And 4,950,000,000. Hopefully that's my bank account. That would be fabulous. But I've got 3 kids, 2 of them are in college. That is not my bank account. This is more my bank account. So let's take a look at how to write this one in decimal notation. Notice again the powers in the power. This exponent is going to move that decimal point. Clearly it's going to move it 5 times. I just need to figure out which direction. But this is negative. And remember, all the negative numbers are to the left on the number line. So I'm going to take this decimal point, I'm going to kick it back 1, 2, 3, 4, 5, and once again fill in all those empty slots with zeros right through here. And so therefore, I'm going to have a 0.000763. Now we need to fill in our placeholder. We put a placeholder 0 here, largely because oftentimes we get kind of sloppy with our decimal points and we just kind of go like that, and then it's hard to see. Well, frankly, folks, the best thing that you can do is make a nice big dark decimal point, but go ahead and fill in that placeholder 0 just to make sure we know, okay, there's a decimal point sitting right there. Now, notice that it started off as negative. It will not end not negative. It won't change its sign. It'll continue to be negative. So I need to keep that negative on there, and yes, that's more like my bank account. But hopefully you can see that this is what happens with scientific notation. I did something wrong here. I felt like that was wrong. There should be 4 zeros there and my placeholder 0. I apologize for that. But hopefully you can see that converting from scientific notation to decimal notation kind of makes it's common sense in a way. Just remember that the power's in the power. So this exponent is going to move that decimal point. That exponent is going to move that decimal point. And go with what makes sense with the number line. If that exponent's negative, move it to the left. If the exponent's positive, move it to the right. Now, let's see how to convert in the other direction. In other words, starting with decimal notation and converting to scientific notation. Now, what a lot of people teach is that means you reverse the rules. To me, that is very confusing to reverse rules. I'd rather stick with the rules that I already know. So therefore, I'm going to stick with this idea that the power's in the power and the power's going to move the decimal point. So what I'm going to do is I'm going to say, well, notice this being written is not in scientific notation, in decimal notation. Scientific notation, remember, looks like this, a times 10 to the n. That's what it looks like. So I want to make this look like that. In other words, I want to have a number here that's written in this way. Ignoring the sign, I want to make sure that it has 1 digit to the left of the decimal point. There's no equal to part here. So it's not going to be a 10. 1 digit to the left of the decimal point. So that means when I take a look at this example and I want that decimal point no longer to sit back here, I want it to sit where I will have 1 digit to the left. So where would that be? Exactly right, between the 5 and the 8. So if I want to convert this into scientific notation, what I'm going to do is I'm going to say, well, it's going to be 5.812 times 10 to some kind of power, because that's what scientific notation looks like. But now if I need to figure out what that exponent is going to be, to determine that exponent, I'm going to see how this decimal point needs to move to go back to my original problem. So in other words, this decimal point, it needs to go first off to the right. Well, this goes back to those old rules, because the old rules said this exponent moves that decimal point. So if this decimal point needs to go to the right, then that means this exponent needs to be positive, because anything positive is to the right on that number line, so this is going to move it to the right if it's positive. So therefore, if it needs to go to the right, my n is going to be positive. If it needs to go to the left, then which way would it go? My n needs to be negative. So like I said, this goes back to those old rules. I'm not changing rules. I'm not reversing rules. All I'm doing is I'm saying, let's make this look like that, because that's what scientific notation looks like, and that exponent moves that decimal point, the powers in the power. So therefore, this decimal point, yes, needs to go to the right, which would indicate positive, but how many times does it need to go to the right? Well, it needs to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times to the right. So I'll have a 10 to the 10th power. And there it is, written in scientific notation. So let's take a look at this one now. Again, scientific notation looks like this. A number times 10 to a particular power. I just need to make sure that this number only has one digit to the left of the decimal point, ignoring the sign. So currently the decimal point is here. To only have one digit left of that, that would mean that decimal point now needs to sit here between the 7 and the 2. So I'll have 7.2 times 10 to some kind of power. Now remember, this is a negative number, so it needs to stay negative. I'm not going to lose that negative sign. I'm going to keep it on there. But now remember, the powers in the power, this exponent moves that decimal point. This decimal point, I need to move it so that it'll look like it's original. This one needs to go to the left to make it look like this. And recall, like we said before, anything to the left on the number line is going to be negative. So that gives me a negative exponent. How many times does this need to move to the left? Well, it needs to go back 1, 2, 3, 4, 5, 6, 7 times. So that means I have an exponent of negative 7. And there it is in scientific notation. And again, it's okay to have a negative in there. I just need to ensure that I only have one digit to the left of the decimal point. So hopefully that helps you with scientific notation. And like I said, it's so helpful when you have some very large numbers like you see right here, being able to convert it into this scientific notation so that you can work with it and do computations with it, which we won't get into in this video. That's another one. And very, very small numbers, write them in scientific notation, again, so that they're easier to work with. So I hope that helps in converting. Have a great day.